This is Geometry Unit 4, Lesson 1 on line reflections. This unit is on transformation. So before we do line reflections, let's talk about what a transformation is. A transformation basically is a change of something. We are going to be mapping points in a plane. We're going to be moving points around in a plane. So let's compare it to a seating chart for a large class. So you have a bunch of students sitting in your class, and you want to move their seats. All right, so each point in the plane, P, which is called the pre-image, maps to a unique point, P prime, the image. So if we took all our students and rearranged them, each student is going to move to a different seat. Okay? So each point P in the plane, which would be the pre-image, maps to a unique point P prime, the image. Each student will move to a new seat. And it's a unique seat. So they're all going to move to a different place, and nobody's going to move to the same seat at the same time. So no two pre-image points have the same image. You can't have two students move to the same seat. No two students will move to the same seat. So if you move the students around, you can't put two students in the same seat. Everybody's going to have their own seat. And also, lines are preserved. If 3 points P, Q, and R are collinear, or on the same line, their images P prime, Q prime, and R prime will also be collinear. So basically, if you compare it to moving students around, students that start in a line will still be in a line. They will still be in a line after they move. So, when you are doing a transformation, every point on your figure that you are moving, whether it's a segment, a polygon, whatever it happens to be, will move to a unique new point. And they will all move the same way in the same direction. So now that we know what a transformation is, let's talk about the first kind of transformation, which is a line reflection. We are going to sketch the reflection of triangle ABC over the line L. So, in a line reflection, the line here is considered like a fold line. We want to fold this figure, triangle ABC, over that line so it ends up on the opposite side. Now, to do that, when you have a line just in space, each point has to be moved straight to the line. And when we do straight to the line, what do we usually call that? We actually call it perpendicular. So when you go, for example, from B, you have to go perpendicular to the line. Now, it's very tempting to just try to draw like this and go straight across, but no, it has to be perpendicular to the line. So this distance right here, from here to here, would be perpendicular. Now, since it's going to the line, it's got to also go to the opposite side. So not only does it have to be perpendicular, it has to go, if it's from B to here, the distance on the opposite side has to be the same. So we just continue the line out the same distance. So B prime would go here, because this distance and this distance on opposite sides of the line should be the same. So it's got to be perpendicular and the same distance on the opposite side of the line. So that will be true for all your points. If we did C, we go from C, perpendicular, and same distance on the opposite side. All right, so this would have to be perpendicular. Distance here is equal to the distance here, so C prime would be about there. All right, now A is actually on the line. So if I fold on the line, isn't it going to stay there? Yeah, it is. So when I create my triangle on the opposite side, it should be a perfect mirror image of what I had originally. So this triangle and this triangle should be exactly the same. If I were to fold on line L, those triangles would match up perfectly. So that is a line reflection. Now, the notation for a line reflection. If I want to say the reflection over line L, so I would say the reflection in line L. that means reflection. Lowercase r means reflection, and whatever the subscript down here is whatever the line is. It could be the x-axis, the y-axis, the line 2x plus 5, whatever you want to do. Reflection line L of whatever you're doing. Now, so we just did the reflection line L of triangle ABC. Whoops, ABC becomes triangle A prime, B prime, C prime. We reflected in line L triangle ABC, and it became its image triangle A prime, B prime, C prime. This is the image. So notice when we changed this, it became, technically it's A, B prime, C prime because A stayed the same, but either way. All right, so when you see a lowercase r with a little subscript with a letter, that means a reflection in that line, and you'll be given the name of the line. So this one was line L. All right, so now that we know how to do a line reflection, let's look at some of the properties that we run into. All right, so the first property of a line reflection. If a point is on the line L, or the line of reflection, what happened? This was point A, for example. Did A move? No. For line L, the points on the line don't move. They stay on the line. That is called invariant. An invariant point is a point that doesn't move. All right, so point A is invariant. The image of A is A, it didn't move. So the reflection in line L of A is A, because it didn't move. All right, so for the points that are not on line L, for example, that would be B and C. What is line L? Well, let's see. We said that the points from B to B prime, going from B to B prime to do the image, this line right here, the segment we just created, is perpendicular and it's cut in half. So that means L is the perpendicular bisector of the segment from the point to its image. So L is the perpendicular bisector of the segment B prime and C prime. So this dotted line segment right here, this line L is the perpendicular bisector of it. That is important when you're having a line reflection. The line of reflection is the perpendicular bisector of the segments that's created by the point in its image. Now the other two properties that we deal with line reflection is distance and angle measure. Distance means the size of the figure that you have. When we did the reflection of the triangle, here's the triangle that we reflected. The triangle changed size? Not at all. AB ended up the same distance as AB prime. BC is the same as BC prime, and AC and AC prime are the same. What you started with is what you end up with. So all line segments will be the same length. So AB will be congruent to AB prime. BC will be congruent to B prime C prime. And AC will be congruent to AC prime. The lengths of the line segments are the same. What you start with is what you end with. We didn't change the size of the figure at all. Now, we also did not change the shape of the figure. If I look at this triangle right here, this matches up perfectly. All the angles are going to be the same. Angle A is the same as angle A over here. Angle B is the same as angle B prime over here, and angle C is congruent to angle C prime over here. We did not change the shape at all. So all of the angle measures will stay the same. Angle B will be congruent to angle B prime, and angle C will be congruent to angle C prime. So the size and the shape did not change, we just changed its position over the line. Now, let's look at some line reflections using coordinates. We run into these a lot, and they're used a lot in geometry, so you really need to know your rules for these. Now, we're going to start with triangle ABC with these coordinates. A is at 5, 0, B is at 2, 4, and C is at negative 1, 2. And we want to draw A prime, B prime, C prime, the image of ABC after reflection in the x-axis. So we are going to reflect ABC over the x-axis. So we want to go perpendicular to the x-axis and the same distance across. So let's look at A at 5, 0. Where is A prime going to be? Well, isn't this on the x-axis, so is that going to move? No, it's not going to move. It's going to stay exactly where it is. So A prime is going to be at 5, 0. So remember, that's going to be an invariant point. That does not move. It's invariant. So B at 2, 4, I want to go to the x-axis and the same distance on the opposite side. 1, 2, 3, 4 perpendicular to the x-axis. 1, 2, 3, 4 to the opposite side, and there is B prime. So B prime ended up at 2, -4. C is at -1, 2. I want to go perpendicular to the x-axis and the same distance on the opposite side. So 1, 2, 1, 2. C prime ends up here. If I connect my points, A to B prime to C prime, and then back to A, I have created the exact same triangle with the fold line as the x-axis. Now let's look at the coordinates that we have here. We might notice something interesting about the coordinates. In general, for reflection of the x-axis, well, this is an invariant point, so that doesn't really help us, but look at B and C. B was at 2, 4, went to 2, -4. C is at -1, 2, went to -1, -2. What happened to the coordinates? Well, did the x change? No. But did the y? Yes, it did. So a reflection in the x-axis, xy, becomes x stays the same, y changes. So x stays the same, but the y changes. So you could do this without having to graph it if you knew the point. For example, if you had the point P 6, -2, P prime would be x stays the same, 6, and the y changes, 2. So you could do it without the graph if you know the rule. So when you're reflecting the x-axis, the x stays the same, the y changes sign. Now let's do the same thing, but this time we're going to do a reflection in the y-axis. So if we reflect this over the y-axis, we're going to go from A to the y-axis, 1, 2, 3, 4, 5, and the same distance on the opposite side, 1, 2, 3, 4, 5. So there's A prime, and that ends up at -5, 0. For B to the y-axis, 1, 2, same distance on the opposite side, 1, 2, B prime would be there, and that is at -2, 4. And then C is at -1, 2. To the y-axis, same distance on the opposite side. C prime ends up over here. That's at 1, 2. Connect your points. You should have a mirror image of the fold line on the y-axis. It looks exactly the same. If I folded on here, all those points will line up. What happened to the coordinates? Well, let's see. Did the x change this time? Yeah, x changes, but y stays the same. So if we write a rule for that, for reflection in the y-axis of xy, it ends up being -x, y. X changes, y stays the same. All right, the last one we're going to do is the image of ABC after reflection of the line y equals x. Remember, the line y equals x has a y-intercept of 0 and a slope of 1, so it's going to split the quadrant in half, like so, and we want to fold on that line. Now, this is a little hard to see when you're doing it, but once you know the rule, it's a lot easier. I'm going to do B first. It's a little easier to see. If I start at B and I want to go perpendicular to the line and the same distance on the opposite side, notice I'm going diagonally. So B prime is actually going to end up right here. There's B prime. So notice here, that's the perpendicular. So B prime actually ends up at 4, 2. Now you can probably predict where the rest of these are going to fall. A, 5, 0, what happened to the coordinates here? They switched. So this is going to become 0, 5. 0, 5, 1, 2, 3, 4, 5 ends up here. There's B prime, or excuse me, A prime. And then C will be, switch the coordinates to -1. To -1 is here. C prime, connect your points. There's, whoops, maybe do a solid line here. A, B prime, C prime ends up here. And if you fold on your line of reflection, they line up perfectly. So your rule for the line of reflection, reflect over y equals x, becomes y, x. So those are the rules of reflection that you need to know.